Absolutely. Hi, everybody. Good morning. My name is Adrian Corona. I'm a data center or cloud infrastructure technical specialist. I work in Naveed's team or with Naveed, and I'm glad to see you guys here. This is my first presentation here with the with the Azure Power Lunch, so I'm very excited about this. And with no further ado, I want to give you a quick overview of some of the stuff that is new in the networking world of Azure. I don't know if you guys followed up any of the new announcements we had last year, or any one of you actually attended Ignite. But let me just share my screen. Everybody can see it?
Yes, sir.
Okay, excellent. Let me start from the beginning. There you go. So there's a nice blog post that I will add to this, but and there's many very exciting things that we announced on the networking side, and one of them is the virtual network service endpoints. So what that is, if you guys are not familiar with, is today when you create a SQL or storage or a SQL database in Azure SQL, you get a public endpoint. You get something like database server1.azurewebsites.net. So some of the security people don't like that, and because even though we have built-in security and we have firewalls and we are pretty good at defending your environment against those threats, the endpoint is still out there. So if for some reason your endpoint is not well secured, then that's a risk. So a lot of people one of the big announcements is that they with virtual network service endpoints, you can extend those endpoints to your virtual network private address space and the identity of your VNet to those Azure services. So technically what that means is that you can restrict Azure resources to only be accessed from your VNet and not through the internet. So that's a very important thing, I guess. And feel free to reach out to any of us in the team. My name again is Adrian Corona. And if you guys like me to talk to you a little bit more about it, but there's a lot of documentation about this specific feature in our website right now. We have another thing that it's not listed in this slide, but it talks about DDoS protection. So we by default have Azure provides customer with that solution for securing and protecting the availability of your application. So we have basic DDoS protection that provides that real-time mitigation to protect your cloud services. But this new service, it's called the Azure DDoS protection, protects your application from targeted DDoS attacks within your network. And that brings additional configuration, alerting, and telemetry. You now can see the type of traffic that it's being scrubbed to your network. You have metrics and alerts that can tell you if there has been a breach or we've having a DDoS alert going on and we're scrubbing your traffic. You will now have the capability to monitor and alert those malicious attacks, right? Application gateway and WAF enhancements. For those who don't know, app gateway and WAF are kind of like a requirement today in any cloud or web-based cloud deployment. App gateway is a layer 7 device control delivery controller, which includes multiple things like cookie affinity, SSL offload, host-based routing, SSL arena encryption, and application firewall. So we have this new ability to do redirections. We have a new SSL policy support, and new support for OWASP, Core Set Rule 3.0, and so on. So again, very, very interesting, very important things that we are supporting now in Spectrum. Network security management had a nice revamp. If you are, and I'm assuming you've been working with Azure for a while, if you are in this call, you know that an NSG allows you to define network access policies based on IP addresses, and you can restrict access to and from VMs and subnets within your VNet. We have simplified this management of network security groups with something called service tags and application security groups and enhanced NSG rules capabilities. So technically, a service tag allows you to create it's a name that represents an IP address for a given Azure service, either globally or regional. Like I have a SQL server, Azure SQL server in West US. You can now use a tag to add a rule that allows or denies traffic to those locations instead of having to come through IP addresses. Application security groups is network security based on your user-defined VM group. So you can group or create your own tags that represents any type of or any group of VMs, and then you can use that tag on your NSG. So, for example, think you have a web server farm, and you want to group those and create a group called web server or application servers, and then use those names in your security policies. That again, that gives simplifies the number of rules that you need to move forward. NSG augmented rules. It's augmented rules for network security definitions. You can have now larger, more complex network security policies with fewer rules in the environment. There is a question from that if I'm showing presentation, is everybody can see my presentation?
Yes, I can see it, man.
Oh, okay.
Yeah, I think
it's just a single slide right now at the far.
Yeah.
I'm getting to the meat of the stuff just here in a second. So let me speed up a little bit because I know we're kind of short on time. The other cool thing is that we just announced Azure being the fastest public cloud in the world. We support now up to 30 gigs per second VM to VM bandwidth. So that's pretty beefy. And it's part of what's called accelerated network. And also we announced 6 times we increased the number, the performance of our VPN gateways up to 1 gig or 1.25 to be exact. And last, monitoring. Monitoring is a big piece of, it's a big request. One of the largest requests I have with from our customers when they say, well, I want to monitor, I have ExpressRoute, I want to be able to monitor it, or I want to monitor my VPN connection. We offer now NPM. We will be starting a private public preview of NPM for ExpressRoute, where you guys, customers, will be able to monitor connectivity end-to-end on their ExpressRoute tunnels. And same for site-to-site VPN monitoring. So you will now provide both either metrics and diagnostic logs giving the throughput of your site-to-site VPN tunnels and have alerts based on VPN metrics, right? Okay, cool. So that's pretty much everything I had to talk about. And there's more information. And again, we love to talk about it about anything related to networking as well with you guys. But today, I think the topic that brought us in is talking of blockchain. So switching gears dramatically here. So from networking to blockchain, that's a big jump. But what is blockchain technically, and why is Microsoft trying to get in the game, right? It's as you know, kind of the market slide, but our digital transformation is a vision that has 3 pillars: create more computing, build intelligent cloud platform, and reinvent productivity and business processes. So on that 3rd pillar, which is reinvent productivity, business processes, we're looking into this technology, and as you probably know, big data, IoT, but now blockchain and innovative technology like AI, bots, and machine learning is activating what's called now the Internet of Value, which is it's a concept that you will probably going to start hearing more and more here in the future. But let's get to the grain of what blockchain is. So blockchain was originally developed for a payment system, if you will, or an asset tracking, and it's basically a blockchain is a decentralized ledger. It's not a database, and I will get into those details here in a second. But a blockchain is a secure digital distributed ledger that uses public and private signature technology to validate and record transactions in near real time. So I'll delve into this here in a second, but what are the advantages of blockchain as a distributed ledger? So first of all, we have security, right? Everything in the blockchain is encrypted and with digital signatures. Now, the blockchain is also shared. So there's potential benefits of blockchain over conventional technology is achieved when we used it to link organizations.
I think Adrian just disconnected. He's coming back, I think.
Hey, can you hear me?
Yeah, I think you dropped off for a second, man.
Oh, okay. Yeah, I'm sorry. It said that I was disconnected,
Maybe
kicked
some.
out of the meeting. Said I'm doing terrible. All right.
Oh,
Sorry about that.
go on.
The
Go ahead.
potential benefits, as I was saying, is when we use this blockchain to link it to organizations to share information as a distributed ledger, and then we have the distributed. A blockchain can be distributed across multiple organizations and can become more secure as replicas are added to the environment. And last but not least, being a ledger. So for those in with certain, if you go back to our maybe college years when we talked about ledgers and things like that, it's every transaction is written into a ledger once and cannot be changed after the fact. So this has great advantages to the financial service industry because we have an auditable trace of every transaction, and there's a compliance overhead is it's for financial services have escalated since financial crash, and this feature of the technology has huge potential benefits for this compliance teams and financial regulators. Now, one thing that is very important to say, blockchain is not, while it makes the most sense for financial aspects, it is not just a finance. If your company doesn't do finance, there's a lot of industries that are benefiting from blockchain use. So just to get into a little bit more of a background of what blockchain is, and we have multiple blockchain types today. So if I guess one of the most famous today is Bitcoin. So if you hear blockchain, oh, Bitcoin, and you hear all this craziness about dudes having, you know, football fields full of network cards and not network cards, video cards, and doing crazy stuff and getting ultra rich from day in and day out. That's kind of the hype. But Bitcoin is just one implementation of blockchain technology. Today we have other multiple blockchains. Ethereum is one of the largest one after Bitcoin, and then we have Ripple and other ones. But we also have things like Hyperledger Project, which is a blockchain created by IBM, or Corda from R3, which is a consortium that we Microsoft are part of, and so much more, right? So again, please, in what if there's one point that I want to come across today's conversation is. Bitcoin is blockchain, but blockchain is not just Bitcoin. It's much more than that. And the second again is this is not just for financial purposes. We have other things. We have multiple network types. So again, Bitcoin could be considered what's a public network, where you have many unknown participants. Today, you can just download the blockchain in your computer and be one more node in the network and start validating transactions, basically. And then there is a consensus, what's called a proof of work, which is the concept of mining, which I don't have time to go over all of that stuff today, but it's a concept where you validate transactions, right? Now, when we extrapolate this concept to a private network or a private network type, the technology is still the same. You still have a blockchain with the same elements, but it could be implemented in a same company where multiple people from from different teams need to share a transaction record. So maybe accounts payable to purchase orders, and then have a paper trail, no, well, a digital trail of transactions. But not just that; it could be way more than that. Digital media and digital records or things like that. But it's all within the same private environment. You only have one. And the next level, which is called a consortium. So a consortium is a multiple participants from multiple organizations working with the same base, a same base blockchain. So think about it as Swift or things like I don't know, any loyalty points like airline points, right? Where you have I have my airline miles, and then I can use them in my airline, but I can then use them in other airlines if I want to. That's kind of part of a consortium, right? Many airlines could be part of the same program and use the points in one airline to multiple airlines, and that's what's called a consortium. Again, the technology is the same. It's a blockchain, and you can choose many different blockchains for it. Each blockchain implementation has a different type of or benefit or acts differently based on what you're trying to accomplish, right? So now you can say, well, I do have SQL, Oracle, that other database, MySQL. I have all these things. Why blockchain? Why a database versus blockchain? What is the difference? So there's a few different differences, big differences. A database or RDMS, it's overseen by a central authority. So whether I can have nodes, but technically there's one central location who manages the entire database and owns it. If it's vulnerable to attack, it's a single point of failure, and it's a matter of trust that I have. If I subscribe to my business partner and they own that database, I have to trust in their security controls to make sure that the data will not be altered or corrupted at any point. Blockchain is different. Blockchain is, we have a consensus algorithm, so nobody really owns a blockchain. So everybody owns a node and has the same visibility across the transactions in the blockchain. And just to, maybe people will say, well, does that mean that everybody can see my balance? In a public blockchain, yes, because that's the point of it, the transparency. But you can have other types of blockchains, applications like Quora or something like that do have the ability to encrypt or obscure some of those transactions. So thinking about a consortium, like a private consortium, when you're talking about deploying a database, a blockchain in my environment, well, maybe there's some parts of I don't want my business, my suppliers to see what other suppliers can do. There's definitely that capability with a blockchain. But the consensus algorithm means that everybody has the same reality, the same truth. And it's virtually, there's a native or natural immutability to the blockchain, which means that I cannot really change a block in my environment. That means that if I wanted to change and say, well, I have $1 million in my account, I will have to hack 51% of the nodes in the network at the same time to kind of realize the fact that they will have to know that change at the same time, and that it's extremely, if not almost impossible to achieve. So it is a very resilient methodology. So again, there's different things. If blockchain, one thing that is very important, it's slow. It's dog slow. In its best days, Bitcoin, for instance, has 5 to 10 transactions per second. Ethereum, it's a blockchain 2.0, has a lot more, but still has 15 to 25. We have made advances in Microsoft that allows you to have 1,600 transactions per second. So if you need 1 million transactions per second, don't look in blockchain. That's not your solution, right? So going back to the evolution, right? So again, I talked about blockchain 1.0, which is what Bitcoin does, right? It's a simple ledger that records transactions. There's nothing into it. It's a trustless environment with this decentralized data, as I was mentioning earlier. Now, blockchain 2.0, which is kind of like what we're looking into today, is the addition of what's called smart contracts and logic tier. So blockchain 2.0 was created by Vitalik Bittering, which is the creator of Ethereum, which introduced this concept, meaning that you can bring your traditional contract into digital logic inside the blockchain, and then this contract logic and properties and all the asset control can be written and invoked and deployed to all the nodes in the network. So when you are trying to sell a car or you're trying to sell a house from one person to another, you just invoke this contract now from the blockchain, and then you have a distributed, validated transaction that it's immutable. So that means that if I'm transferring funds to you in payment for your house, I can be rest assured that those funds really exist in my environment, and I really have them, and that the transaction is the or the asset movement or asset transfer has been performed correctly. So again, I'm just glancing through because I know we're kind of short on time, but the next step is blockchain 3.0, as we like to call it. So Microsoft is actually building unique technology in this space to allow you to link your blockchain solutions to your existing technology investments. So an example of this would be to integrate a blockchain with your company directory and your employees' digital identity. So one of the constraints about blockchain is it's a very isolated island. Given the immutability of blockchain, that means that you cannot bring the oil prices into your program or your contract very easily. It's just not allowed. So we are creating this thing called cryptlets or oracles, as we call them now. We can now allow the blockchain to access external data securely while maintaining the integrity of the blockchain. So the cryptlets of oracles are a Microsoft innovation and solve significant problems in enterprise blockchain adoption, right? So what are the potential benefits of blockchain? Now that we talked about it, a blockchain eliminates intermediaries, which means as we've seen how this removing the intermediaries has transformed industries. So like travel industry or music industry, like you see a Spotify or things or Uber. And you have blockchain scenarios have the potential to disrupt every industry. For financial services, this poses significant threats and opportunities. I have to say that Microsoft does not believe that the financial services industry will disappear, but blockchain will help it to evolve to provide increased value services and focus more on their relationship with their customers. Now, we can also reduce fraud. That means that blockchain keeps a historical record of every transaction that cannot be changed. That's the key of it, immutability. It can be made viewable to certain parties, but not to everybody. And then you have smart contracts, again, can transform processes both inside and outside banks. So I will talk a little bit about it, but the potential benefits is driving the predictions for savings in the financial industry, as an example. And so let me just go into a little bit of business. Again, I've been talking a lot about financial services, but this is just an example of all other industries, how they're doing. Like you see retail or construction.
There is one question on the IM window. It's around blockchain and quantum computing, because the question is, will blockchain survive quantum computing considering current
That is a great question. So I will get to that in a second. But the short answer is it'll be still very difficult because quantum computing is not it's just super fast computing. It's not the way to hack a blockchain. It's not about how fast you can do it. It's about, well, let me rephrase that. It's not like you want to crack a SHA 256. It's not about cracking a digital signed environment. You have to modify a record in every node that is part of that blockchain. So it will become extremely difficult, even I guess from quantum computing, to do that. Now, let's play out the scenario where you find yourself in an environment where you have access to quantum computing, and then you can somehow hack all those nodes. there's processes in which you can, like we just created something called Cocoa framework, which allows you to do something very special, which is it works. It's a combination of hardware and software, but it's basically you have a hardware enclave which has a attestation of that operating system, and it's completely black, like it's completely darkened to us. And there's once you make that attestation, and I'll get to that. I'm getting a little bit ahead in the presentation, but I think that's okay. Once you create that attestation, there's there's absolutely no contact from the exterior. We will not allow communication from anywhere else but other nodes in the network. So you kind of like you create this network in such a way that once you set the initial configuration, say I have this number of nodes, I have the security assurances and this attestations, there's nothing that can modify this blockchain unless it's coming from any of these other nodes. So quantum computing in that sense, it doesn't matter if it's quantum computing version 3.0, it still cannot break those rules, if you will. So I know I'm just oversimplifying this, and I would like to, if you like, we can take this offline anytime, just to go over those scenarios to be more clear. But technically, it is very, very hard in the way blockchains work. So with that, I just want to go a little bit about it. Why it's Microsoft? What's Microsoft doing? So Microsoft is not building a blockchain. So we are not creating our own blockchain. We are instead an open ecosystem for blockchain developers to build their stuff in Azure very quickly. But also, we are trying to create a platform where you, as a customer that wants to just fail fast and do a quick POC on blockchain, do that and the cheap and very easily and very quickly. We have a project called Bletchley, which is basically creating it has the manual infrastructure coding, and we provide the cryptlets that I was telling you about. We create this middleware in between the blockchain and your end services. But also we have Microsoft Blockchain as a Service. You can go into our portal and deploy an Ethereum blockchain consortium. We have pre-created a Ethereum consortium for you, which normally takes 3 to 4 weeks at least to build all those components by yourself. Now you can spin up a blockchain in 15 minutes out of the Azure portal, very quickly, very easily, and again on the cheap, because you can very, very quickly choose what type of nodes you want, and you can be running a blockchain test for maybe just a couple, maybe $100 or so. So it's very, very, very powerful the way we're doing this. So again, Microsoft wants to try to simplify all this. This is what a normal blockchain architecture likes. So this is what takes 2, 3, 4 weeks or more. We are simplifying all this for you and just dumping it out and managing it for you and giving you the availability to just create your solution or just test it out. Let's say I want you to create a new network, a new node, and play around with it without having to deploy all this madness that I'm talking about. So that's kind of Microsoft's end goal. And again, Cocoa framework is, and I spoke to it a little bit earlier, but it's and there's a nice white paper from Microsoft where we talked about what are the benefits. But Cocoa is kind of like 3.0 blockchain, where it's hardware. It works with Intel SGX hardware and other vendors that create this super secure environment where once you attested that environment, it cannot be accessed or modified by anybody at any point. So it provides a lot of benefits. One of it is the energy efficient. As I didn't delve into it, but mining it's a big process in which we do validation of transactions. So having mining out of the equation is what Cocoa framework does. Since we are certain that the security of these transactions are valid. We don't have to mine those transactions. We don't have to validate them. We are already guaranteeing that those transactions are valid. So you don't have to to spin up those mining nodes that are consuming a lot of energy across the globe. You have distributed governance. What means that you can have multiple nodes across. And in CocoaNet framework, it's something that it's initially going out live in Azure, but the white paper specifies clearly that you can deploy those type of nodes on premises on other hypervisors. It's a really open framework for us that we are enabling others to use. So if you kind of to close into the thoughts today is, where are you in right now? So we kind of break it by 4 levels, right? What 80% of people is today is no blockchain experience. There's no identified scenario. You just kind of dipping your toes. This is kind of on the right hand. You can see the type of things that we as Microsoft can help you with. You need a briefing. You need a strategy or architecture workshop. You need a technical training, lab setup, hackathon. Those are everything in the right column is things that Microsoft can help you with. Some of them will be through your TSPs, some of them CSAs, or some of them could be through your MCS consultants as well. So you can identify yourself in these 4 levels and request for help from your account executives or any of your Microsoft people about getting engaged with blockchain as well. So I guess that's it for my presentation. I know I super glanced. Normally, blockchain is a very complex topic that requires much more time, but I'll be happy to answer any of your questions. My email, it's acorona@microsoft.com, acorona like a beer. It's easier to remember on a Friday night, so just shoot me guys an email, and if at this point, I know I'm over time, but I'd just like to know if there's any questions.
Hey, Adrian, thank you, man. I know it's a very complex topic and hard to cover, but thanks for providing an overview and kind of next steps. By the way, you're going to be sharing that presentation. Is that
Absolutely.
Okay? Perfect. Guys, any questions at this time?
Hey, Adrian, let me know if you can hear me. But can you talk a little bit more about Project Lexington? Right, the whole idea that we can do POCs within a couple of days, and then also list out some of the advantages of using Ethereum. Thanks.
Sure. So Ethereum, as I was mentioning, one of the benefits of Ethereum is it's inserts this, and let me just go back in the presentation if you're still on the call, but Ethereum gives you or introduces this concept of smart contracts. So smart contracts is it's something that is just enabled in blockchain 2.0, which is Ethereum. You cannot do smart contracts on blockchain 1.0, which is Bitcoin. So if you must have those type of contract logic in your blockchain, that's where you need Ethereum. To your first question, the Project Lexington, and that's a great point. It's that's something that so like what I showed you here is the blockchain as a service, and Project Lexington it's a code name for the ability for you to create a POC from the ground up very quickly. So we will provide all the infrastructure. We will automate the infrastructure deployment and also the front end. Because the blockchain as a service today, we deploy, what I'm showing here in my screen is we are deploying a, let's see if we have a diagram, but technically what we're deploying is just a bunch of nodes in a couple networks, and but there's no front end. You still have to validate or create your own interactions with that or your business logic. Lexington is the ability or what Microsoft's effort to give you those capabilities right off the bat, where you can very simply end up with just a Northwind Traders web application that is relying on blockchain for you to test up your environment or test the blockchain capability. Does that answer your question?
Yep, thank you.
Awesome. There's another question from Ryan Scott. When you automate all the server nodes in the environment, who's responsible for patching, updating those servers? That's a great question, Ryan. When we talk about like this environment, Azure Blockchain as a Service, we use Linux nodes, and they still need to be patched. it's an infrastructure as a service. So you or the customer, it's still you still need to maintain those nodes or those servers. The automation is think about like a VM template today. We have a lot of VM templates in Azure that can create, I don't know, a SQL farm or a SharePoint farm, but technically once it's created, you still, if it's talking about IaaS, you still have to maintain that. So blockchain as a service, it's based on IaaS as well. So you still need to maintain those nodes yourself. There is no PaaS blockchain, if you will, if that's what you're asking. Does that make sense?
Yes, that makes sense.
Excellent. So the question from Ryan, it deploys into an Azure 10.8 VNet, best way to get into it. So even if that's the case, it's still deployed in a virtual network. So it's IaaS, so infrastructure as a service. It doesn't matter what type of IP address you have. You can SSH into those VMs because you get a public SSH endpoint to reach into, like a master node, if you will. Also you have the ability to tweak the template to, instead of using a 10.8, you can use any other VNets to your liking. So you can deploy this the way you like it. And that really only matters if you're planning to for this blockchain deployment to be connecting to your network. If it's just a POC, it really doesn't matter which IP address.
Gotcha. Thank you.
Awesome. Any other questions?
Go ahead.
Oh. Any other questions, guys?
Okay.
Awesome.
Thanks, Adrian. Thank you very much, man.
No problem, guys. It was a pleasure to talk to you all today, and thanks for breaking up your Friday. And I hope you have a good rest of the week.
Thank you. Thanks, everyone. Happy Friday. Happy Friday, everyone. See you next week. Bye-bye.
Okay. See you. Bye.